In this video, we're going to show how you can use half-angle identities to find the exact values of angles that we don't know the exact values are by themselves. So what we're going to use is the sine of 75 degrees. 75 is half of an angle that I know the exact value of, and that value of that angle is, if I just take it times 2, I can always find that angle. It's the sine of 150. So what we're going to do is we're going to take that sine of 75 and we're going to rewrite it as the sine of 150 divided by 2, which is exactly the same as sine of 75. Then we apply our sine of a half an angle, so up here. So what we're going to do is we're going to say that's equal to a plus or minus the square root of 1 minus the cosine of your angle theta. Now theta represents 150. It's theta over 2, so 1 minus the cosine of 150 divided by 2. I'm going to go ahead and take care of this plus and minus. The plus and minus here is so that you can decide if it's going to be positive or negative. Because it's a first quadrant angle, we're going to find the sine of a 75. It's in the first quadrant. It has to be positive. So I can eliminate the negative one, and all I need is a principal square root. So I'm going to drop the sign completely. It's the square root of 1 minus. Now I'm going to do the cosine of a 150 degree angle. If we do a 150 degree angle, that means our reference angle is 30 degrees. Opposite the 30, there's our square root of 3. There's our 2. Not 21, but a 2. What I need is the cosine is the adjacent over hypotenuse, which would be your 2. So it's 1 minus a negative square root of 3 over 2, and that's all over 2. The minus and negative becomes a positive, so it's the square root of 1 plus the square root of 3 over 2. That's all over 2. We want to collect our like terms here, so we want to be able to add, so I'm going to make this 2 over 2. Instead of a 1, so that's going to be equal to the square root of 2 plus the square root of 3 over 2, and that's still all over our denominator of 2. But dividing by 2 is the same thing as multiplying by a half. So it's 2 plus the square root of 3 over 2. We got to take that times a half, and that makes it 1/4. So that means it's equal to the square root of 2 plus the square root of 3 all over 4, and then we can break up the radical. Remember, we had a rule that said the square root of a product is the product of the square roots, and this one, the square root of a quotient, is the quotient of the square root. So the square root of 2 plus the square root of 3 all over the square root of 4, which is equal to the square root of 2 plus the square root of 3 all over 2. And that's our solution. Okay, now we're going to go back and we're going to apply another half angle identity. If you got tangent of 7 pi 12ths, then what we want to do is think of, this has got to be half of an angle, so what I'm going to do is actually going to take it times 2 or double it. So if I double it, just like I did, double it, 75 was 150, that's going to be 7 pi 6. So this is the tangent of 7 pi 6 all over 2. Again, if I undo taking and dividing by half, I'm multiplying by, or dividing by 2 is multiplying by half, it's the same 7 pi 12ths. The advantage of this is we know the exact value for the tangent of 7 pi 6, or it is one of our reference angles we know the exact value of. Of the 3 different forms, we can use any one of the forms. I'm going to choose to use the middle form because it doesn't have any radicals involved, and then the denominator is just a sine of theta. So it's 1 minus the cosine of 7 pi 6 over the sine of 7 pi 6. So now what we're going to do is we're going to evaluate 7 pi 6 for both of them. So 7 pi 6, 6 pi is here, so 7 pi 6. And pi 6 is the same thing as a 30, so we got a 1, square root of 3, and a 2. These are both negative because we're in the third quadrant. So they asked us to find 1 minus the cosine of 7 pi 6, and that's a negative square root of 3 over 2, all over the sine of 7 pi 6, which is a negative 1/2. And now we have to simplify again. So we'll get our common denominator 2 over 2. That's the same as 1, so it's going to equal 2 plus the square root of 3 all over 2. And then this time it is divided by negative 1/2. So instead of dividing by negative 1/2, we're going to end up multiplying by. So dividing by negative 1/2 and end up multiplying by negative 2, and that was all over 2. Take it times negative 2, or negative 2 over 1. 2's will cancel, and we'll be left with the negative to distribute to our 2 and square root of 3. So it'll be a negative 2 minus the square root of 3. Okay, so there's an example of how to use our half angle identities to find the exact values of some angles that we couldn't find exact values of before. So again, falling under our double and half angle identity theorems.